Right, well, good evening, everybody. So we're going to start our third lecture this week, and we're going to continue on last week's work, basically, which is Python fundamentals. So I'm going to create a new notebook in the drive, and I'm going to call it lecture 3 Python class. All right, great. All right, so last week we were working with Python data types. We went through lists, dictionaries, and tuples, basically, which are extensively used. And let me maybe, if this is too small, let me know. But anyway, I'm going to be typing here. So, okay, so we're going to just continue building on our knowledge on the topic. So what I wanted to check today was the idea of booleans, because these will be extensively used, and I mean they become extremely important as you build on, learning how to code in Python. So what's a boolean? Basically, they allow us to convey true or false statements. For example, if I say 4 is bigger than 8, obviously we know that 4 is not bigger than 8, yeah? But how does the program process this? So if I press Shift Enter, obviously it's going to run the code. Sorry, it's like initializing only. Right, so it gives me a false statement. Okay, and if I say 4 is bigger than 2 and Shift Enter, okay, so it outputs true. But I mean, how do we use this? Where is this going to come handy, technically speaking? It comes in when you want certain operation to happen. For example, imagine you look into your fridge in a typical, human everyday living. You want to buy eggs. You look in your fridge and you see you have 6 eggs. Let's say you consume, I don't know, 2 eggs every day. So when you look at 6, that indicates to you that you have eggs for the next 3 days. So in a sense, your brain is doing it already. So if it's more than 2, you don't go to buy anything, basically, yeah? But if it's basically getting close to not having any eggs, you end up going and making a decision to buy, okay? So that's how your brain processes. And we use the same logic when it comes to using these Boolean statements, okay? So I have a statement here. For example, we use the if statement. If 4 is bigger than 8, okay? Okay, so if 4 is bigger than 8, do something, okay? So I'm using the if statement. I'm putting the condition, which is 4 bigger than 8, and now I have the column, okay? So I'm going to press enter, and if you notice, we have an indentation happening here, okay? This is extremely important when you start programming. Now, the indentation indicates that whatever is going to happen would only happen if this if statement is true, okay? So is 4 bigger than 8, then print just yes, okay? Let's just try that. So I'm going to run it, and nothing happens, okay? So if 4 is bigger than 8, print yes. Well, nothing technically happened. Why is that? Because the condition was not met. The output was a false. Since the output is false here, so false output, yeah, then the rest of the code, which is conditioned upon the if statement, yeah, this is conditioned on the if statement, is not going to be running, okay? So you don't get anything happening, all right? Whereas if I put the same thing, if 8 is bigger than 4, okay? If that's the case, then just print yes. So if I run that, obviously you get the yes getting printed, all right? So the Boolean statements, we will get to if and else statements and for loops in a bit, but I just want you to sort of appreciate what's the idea behind these Boolean outputs when we use them. Okay, so usually you use them to control the flow of your code. Okay, now that code could be anything. Basically, it could be doing any calculation, any modeling. It just enables you to set a condition for the code to continue along or not. Okay, so that's what it is. Now, let's go to the next section. Now, you can use any of these symbols, these operators, to generate a Boolean. Okay, so remember, if I say A equals 2, here I am assigning A to number 2. Okay, that's what it means. So if I call A is number 2. All right, but how do I check if, for example, A is equal to a particular number? So if I say A double equal sign, let's say 4, I should be getting a false. Okay, so it's just, this operator is basically enabling us to generate true or false, basically a statements, okay, that we can use. Is it equal to 2? Of course it is. Yeah. So don't mistake the two equal signs with the single equal sign. That is for assigning some variable to a name or whatever. And this is actually the operator that you use to check if two values are equal. What if I want to use A is not equal to? So we use this symbol. So is not equal to 2. Of course, we know it's equal to 2. So I should get a false, because A is indeed equal to 2. Now, the bigger and lower and smaller, of course, we all know that. So is A bigger than 4? Sorry, is A bigger than 4? Of course, it's not. So I'm going to get a false. And is A, which is number 2, smaller than 2? It is giving you a false as well. All right. Is A smaller than 4? Of course. But then we also like to use if greater than or equal to. Yeah. So for example, in this case, is A smaller to 2? Well, it's false because A is 2. It's not a smaller than 2. But how can we use equal to or smaller than? Of course, we can go by saying, for example, A bigger or equal to 2? Of course it is, yeah. And is A smaller or equal to 2? Again, we get true, okay? Because A is 2, so either of the conditions is met. So definitely practice to memorize these symbols. These are very important, okay? And we would be using them, or you would be using them extensively in future, all right? So these are the comparison operators that you need to be well familiar with, all right? So that's comparison operators covered. And here, these are some basically examples here. We can also control text. Yeah. So apart from numbers, we can also control text. Like, is Ali equals to Ali? Yes, it is. Yeah. This is when you want to check basically a particular string against another string in future, but you don't need to think too much about it at the moment. Just know that this can also happen when you want to compare two strings. But pay attention to something. Ali equals to Ali. This indeed will give us a false statement. Why? Because it identifies the capital and lower level Ali, basically. Yeah. So bear this in mind, that we can do this as well, but we can get to this in future. All right. So this equal operator can also be applied to strings, okay, provided that the lowercase uppercase is respected, basically. So they need to be exactly matching, in other words, right? Let's use the and or and not as statements along with the operators we just learned. So is 8 bigger than 3, which it is, of course, and 2 is smaller than 6. All right. So if I run that, I get true. Here, remember, here to get a true condition, both need to be true. Okay, very important, because we use the AND statement. Yeah, the AND statement, when you use it, it means that the both conditions that you apply should be met. Whereas if I say 8 is bigger than 3 and 2 is bigger than 6, so one condition is correct, the other is false. Okay, so overall I will get a false output from this code. Okay, now sometimes you may be writing your code and you want either of the two conditions, provided that they are met, you want a true statement. In that case, you would use the OR. So if I say 8 bigger than 3 or 2 bigger than 6. Now here, the first statement is true, the second is false. But because we are using OR, only a single condition is enough. Okay, you can have both of them being correct and still it gives you true, but provided that one of them is also correct, it would give you a true output. All right, and then of course the not, most of the time you would be using and or, but sometimes depending on the nature of your code, you may come and you may end up using the not as well. Not means, okay, so 10 equals to 10. Definitely, I know all of you would be saying, yes, that gives true. Yeah, and of course it does. Yeah. But what if I go and I say, let me just write it on a different cell. So not 10 equals 10. Okay. Just pay careful attention to this. So 10 equals 10 is true. Not 10 equals basically 10. In other words, it's like saying 10 is not equal to 10. That's what it means, technically speaking. All right. And of course, you would get a false. Yeah. But as I said, this you would probably use much rarely compared to and or statements. But provided that you understand what it does, so when it comes to a condition or a situation that you need to use it, then you just use it. Okay. Let's go now. All right, let's get to some cool parts. So control flow in Python. So when we want logic to execute a code that we want to, yeah, only when a particular condition is met. We already touched upon it a little bit, yeah. So earlier on, you know, when I said if 4 bigger than 8, do this or that, yeah, print this, print that. So technically, that's what we were doing. All right, we were doing a control flow, yeah. And these are statements allow us to control the flow of the program based on that, you know, condition. All right. Now let's go and look into the syntax. Yeah. So if, elif, and else statements. All right. Now we already looked at if in a very simple form. Okay. So if it was if 4 is bigger than 2, print yes. Okay. Or if 8 is smaller than 6, print no. All right. So it goes like if some condition is made, whatever condition that is, like that you want to define, and you execute the code. But what I want you to now pay attention to, yeah, so control flows. Okay. What's very important, so I would put it here, please pay attention to the indentation. Okay, very important. All right. So whenever you use the if, else, elif statements, okay, you need to indent what you want to be executed with respect to if. So if I say if 4 is bigger than 2, which we all agree is correct, yeah, print Yes, it is, let's say, yeah. So if I run that, perfectly fine. It runs, it's a true condition, and it will go and execute this. But now pay attention if I don't include this indentation and I go like that, okay? What do I get? You get an error. Of course, you can sometimes read the error and understand what's happening. So it says indentation error. Expected an indented block after if statement, okay? So it won't work if you do not indent it, because the if expects the if statement expects an indentation to take it under the cover of its if statement. At the moment, this print is running independent of the if, and because you get an error at this stage, nothing else happens. You generate an error file, okay? So indentation is extremely important. All right. And now that we're going to like do some examples, let's take a closer look at this. I have a feeling this is a bit too big. Okay. Now let's do this. So I'm going to say A equals 2, B equals 5, and C equals 8. All right. So I'm assigning 3 letters to 3 numbers. All right. So that's saved in the memory. Okay. So now let's mix sort of what, like stuff we learned with print statement and all that. Let's just try to implement it, so make our understanding a bit wider. So if A is bigger than, all right, what am I missing here? I've put on the code here test, yeah, but I don't have the test here. So let's just put test value equals 0 in this case as well, yeah. So if A is bigger than test, which is 0, all right, do something. And what do we want it to do? To print, yeah? Print, print f string is bigger than the user. Okay, I'll use the dot format. Bigger than. I made a mess in there. Sorry. All right. So if A is bigger than test, okay, if A is bigger than test, print A is, I'm just going to put actually A here, is bigger than technically test, yeah? Now in the example there, I have the dot format method, but it doesn't matter. What I'm trying to say is that you run this and you got a report basically coming out. So for example, this is if A has been some parameter, you have carried out some algorithm, has done loads of calculations, and the test value has been generated, and you want at the end of your program the if statement to work toward printing or reporting something for you, okay? So technically, this is a further expansion on the earlier if we did. But then let's look at the if statement, sorry, else statement. Yeah. So if and else statements go together, you don't ever go like else something on a new cell. It usually is used when there is an if statement. Yeah. But let's try that. So if, in this case, B is not equal to A, okay? So if B is not equal to A, which they are not, 2 and 5, all right? We're going to say, if they are not equal, print not same numbers, okay? All right. But what if they were, okay? So what if they were equal numbers? This is where the else comes through, yeah? So I would be like else print same numbers. Okay, so please look at the logic. So I'm checking B against A. If it generates a true output, it would print that they are not the same number. In this case, they are not. Okay, so it would print not the same numbers. Else, print they are the same numbers. So I'm going to run this, and it says not same numbers, okay, because he went and run that. What if I come and change A here? So I'm going to just make A 5 as well. All right. So now both A and B are 5. So it's going to check, is B equal to A? Of course, sorry, not equal to A. Of course, it's a true statement. Yeah, it's a false statement because now they are. I'll just change them. Okay. So this becomes false now, and this becomes true. So now it's going to skip that, and it's going to use the else to operate the rest of the command. So if I run this now, same numbers. Okay. So this happened after me changing the B. But if I repeat this now again, just for the record on the code. So if I say, this time, let's just see, isn't it? Okay. Not the same. And again, I want you to pay careful attention. Okay. Notice the indentation. Yeah. And notice the indentation here. So please understand that we use the if statement. If there is anything to happen, there is an indentation here. The else is not indented with respect to F. Okay? It's not indented with respect to F. Else is like acting alongside if, but sort of independently. But then the print statement for else is also indented, yeah, so that it can be operated provided that the other condition contrary to that one was met. All right. All right. Let's go to else elif. All right. So I have a little example here. So we have a car assigned to as BMW. Okay. So we have a car which is called a BMW, and we are using an if statement. So if car, I'm talking about this example here. So let's make this a bit bigger. Okay. So car equals BMW. If car equals Ford, okay, which is not, print it's American. Else if, that's another statement. Elif car equals Toyota, print it's Japanese. Else, it means any other condition that is met, just print it has to be a German car. Okay. Now take a look at this code. Inherently, this code won't generate any errors or nothing, but philosophically speaking, there is an error with this. Yeah. The error with this is that, so if the car equals Ford, it's American. If it's Toyota, it's Japanese. But then we know there are other car manufacturers like, I don't know, Suzuki, Hyundai, which is Korean, or I don't know, Seat, which is a Spanish, I think. Yeah. So in a sense, we are categorizing any other brand to be German. Okay. So this has nothing to do with the code. You might be like, then why are you telling me this? Yeah. What I'm trying to tell you is once you run the if, elif, and else statements, yeah, it's up to you to implement the right logic in there. Okay. So while this is correct in terms of being a Python code and it works perfectly fine, and it will just, if you put Ford or Toyota, it will give you these outputs. Otherwise, it just says German car. There is no error. There is no mistake in the code. But in terms of logic, there is a problem because it's not taking into account that there are other manufacturers out there. So in future, when you use the if, else, elif statements, it's so important that you appreciate the fact that you need to input some of your own philosophy in there, depending on your statement problem, on what you're trying to do, what sort of calculation, what sort of algorithm you're trying to run. Hopefully, when we get into more advanced part of the course, yeah, and we make examples and we run codes, you would become better familiar, or like expert at creating the logic. But I want you to right from beginning understand that especially with if, elif, and else, it's very important that while you code right, your logic and the idea, the philosophy behind it is also correct. Yeah. Yeah. So that's that. All right, now let's go to for loops. Okay, now for loops are extremely important, super important, because they allow us to iterate. Iterate means, going through basically of something, iterating through something, yeah, looping through something maybe. Well, that's what they call for loops. So you can iterate over every item, for example, in a list, or every key in a dictionary, or characters in a string, or items in a tuple or whatever, yeah. And for loops enable you, yeah. So if you consider a list as a package, like something you have, the stuff that you have in your bag, like let's say you have this bag and you have loads of stuff in it, and you want to take every item out one by one and evaluate what is there, what is not there, what do you want to do with it. Looping is basically what you do in real life. You just go there, you open it up, you pick your stuff out, and you do what you want to do with them. Now in Python, because your data objects are lists, tuples, dictionaries, these sort of strings, and you want to loop through and do something, would it be a calculation or operation? You use the for loops. Okay, so let's start making some examples now. So for loops. Now I'm going to call my tuple, just my top, equals 1, 2, 3. All right, very simple. That's my tuple. All right. Now, let's make a very simple example of the for loop. All right, so I'm going to say for I in my top, which means my tuple, print, in this case, item. Sorry, I. All right, so if I do that, I just get 1, 2, 3, 4. All right. This was in its most basic form. Yeah. So for item, I mean, you can put anything here. You can put uh, item, or you can put any name that you want. But usually the convention use I because it's short and like quite easy to use. So for I, meaning for item in my tuple, print I. Okay. How about this? Let's say we want to, let's make it a little bit more sort of one step ahead now. We want to do some mathematical operation, like, I don't know, times by 2 or a square it or something, yeah? So I'm going to say for I in my tuple, yeah, my tuple, print I squared, all right? So as you see, that's my tuple. The for loop, this command, enables us to loop through all the elements in this tuple, square them, and then print them out. Okay, so that's a very basic sort of example of it. Now, here I have put a list as well, and it's exactly the same thing. You can just walk through it and basically square it there. So I've put a set in there. I'm not gonna, because we have shorter time, I'm not gonna like spend more time on it, but this is on the video. So when you watch it, I encourage you to sort of create a list and loop through it. But at its core, this is what a for loop does. It loops through elements of your data object, okay, irrespective of what it is. Well, not any data set, but a tuple, a list, or a dictionary. Now, let's see if we have a dictionary, yeah? Shall we say, let's just go with that, yeah? So my dictionary, let's create a dictionary, yeah? So my dictionary equals, all right, let's give the key pair values. Key one is, I don't know, a list of 1, 2, 3. And the second key is, I don't know, 6, 7, 8. Let's just go with the slide example. Okay, so that's my dictionary, right? This is a dictionary. And now we want to loop through this dictionary. So we looked at it, we saw how in the tuple, in its simplest form, it was doing it. Basically, it was looping through every single item. So let's just go and print this. So this simple method, let's try it with the dictionary. So for, I don't know, let's call it for, I don't know, for G in my dictionary, okay, print G. Have you noticed what happened? So when you're looping through a dictionary, okay, uh, it is looping through the keys. Yeah. So shall I put that here? Notice that looping through dictionary acted on the keys. Okay. Um, this is very important, yeah, so that you understand what's going on. Because when you're looping through dictionaries, it's a bit more you need to be a bit more sort of engaged with the code than when you're looping through a list, for example, a basic list. Yeah. So what if we want to get these items by a loop in a dictionary? So I'm going to say for I in my dictionary, okay, for I in my dictionary, print, so far the same thing, my dictionary G, okay? What if I do that, all right? But before I do that, let's have a reminder. When we wanted to call up my dictionary, I mean, this was my dictionary, right? Sorry, my okay. So if we go, just put that. All right. So this was our dictionary, right? And if you notice, my dictionary has keys and elements to it, yeah? What if I wanted to, I mean, forget about the for loop for a second. What if I wanted to get these values associated to key one? I would be like my dictionary, and then I would put K1, okay? I hope you remember this or you have practiced this, yeah? Now look how I'm structuring my for loop, because when I put for I in my dictionary, if I say print, let's just do that, we did it here, isn't it? Just print G, he only brought the case, the keys of the dictionary, yeah? Whereas we want the values to come out. So what I do, I put the dictionary name and I put dictionary bracket I. Take a notice, pay careful attention to this to understand what's happening here. So while the for loop on the dictionary picks out the keys, we are inserting those keys into a command like that to print the values associated with those keys. So if I run this, now I get the numbers. Otherwise, as you noticed, if I did this, yeah, for item, for I in my dictionary, print, if I had just I would have got the keys. Very important. I mean, at the moment, all I want you to do is to just appreciate what is going on. Yeah. But in future, you will notice that this makes a huge difference, because especially when you want to explore the data from a dictionary. Now, there is this thing that is quite important. You know, like the dictionary had some commands to it, like items. Yeah, so let's look at our dictionary. My dictionary dot items. Okay, this operation on a dictionary, all right, it generated something. Okay, what is that? That is a tuple, in fact. Yeah, so it's like as if it's a tuple within a list sort of thing, you know. Let's see, yeah, if I put this print, okay, did it make it look better? So we got the keys, we got the values, okay. Now the dot item does that for you. So when you call it on a dictionary, it separates the keys and the values, and it packs it in a tuple. Okay, so that's a tuple in there. All right. What you can do with for loops, you can perform tuple unpacking. Okay, so what does that mean? Okay, so this time I'm going to say for I, comma, j in my dictionary, but not just my dictionary, yeah? I'm going to call dot item function. So in a sense, I'm saying for I, comma, j in this, okay? Dot items, okay? Now I'm going to say print I and print j, okay? So what this is going to do, guys, yeah, what this is going to do for I, comma, j in my dictionary, this process, you're trying to unpack this tuple. So this is a tuple that is being generated by dot items, okay? And you are going to unpack it by using two values here, I and j. You could use k and l or f and b or z or c. The order by which this operates is that it unpacks the elements within this tuple consecutively. So I will go and pick the key, and j goes and picks the values, which is a list. It's a list. So print I and j, okay? Now, that's what you get. So it goes through, sees the first tuple, unpacks it, and prints I, which is k, j, which is the list of values, then goes to the second key, okay? Again, prints I in the second key and j, okay, and so on and so forth. I highly stress that on your own time, you further practice with this to fully understand this idea of tuple unpacking and how you explore a dictionary and how you walk through a dictionary with a for loop, okay? But I'll leave it to this unless I have anything more here. Cool. Yeah. So definitely explore this further yourself with more practice. I will try to give you some exercises as well, but this is one area that I really hope that you guys pay a lot of attention to. Yeah, because this is at the moment in its simplest form. And that's what I try to do when I teach. Yeah. Uh-huh. Mhm, mhm. Of course, you can have I, J, K, L, M depending on how many elements are there. Okay, so let me yeah, so look at yeah. If I just maybe I show tuple unpacking like this, yeah. K, L, M, okay, equals, yeah. This is the logic fundamentally, this is what's behind it. 1, 2, 3, 4, okay. So I, J, K, L, that's 4 elements, right? So if I run this, okay, not enough values to unpack. Okay, look at the arrow. Expected 5. Why did it expect 5? Because I, J, K, L, that's 4, but then we have M. But it got 5, right? So if I put, let me actually leave this so the error is there. So if I do that now, and I say 5, I don't know, 6, whatever, yeah. Now if I call these numbers I, okay, because technically this is a tuple. Okay, so technically, I know like last week I said like tuples usually are defined by the parentheses, but really when you put commas, you have created a tuple. Okay, so in a sense, we are unpacking them here. All right, but provided that whatever elements in the data, whatever stuff that you want to unpack, the number needs to match what you are unpacking, basically. Does that make sense? All right, cool. No problem. Thanks for asking. That was a good question, actually. All right. Now this is another example of a for loop. Well, it is not anything new, guys. So it's a for loop mixed with the if statement. All right. So let's just explore it. Maybe I don't run it, but rather you can run it on your own. But I'll go through it in case there is still something, some guys have a question. So I have a list here. 1, 2, 3, 4, 5 to 10. Okay. So that's my list. And I'm looping through my list and I want to perform something. I want to identify the odd and even numbers. So I'm looping through my list and I'm putting a condition. Now, what is that? I percentage sign 2, okay? Now, just a reminder, what does this mean? Yeah, so this operator. So if I say 10 divided by 2, guys, I would get 5, right? 10 is perfectly divisible by 2. Yeah, you get 10 divided by 2, you get 5, and there is no remainder, no residue. All right? But what if I say 10 percentage sign 2? Okay? I get 0. What this means, yeah, output the remainder of the division. So if you notice, using this can indicate whether a number is divisible by the other number if it's 0. Okay, so for example, 9 is definitely divisible by 3. So if I put 9 percentage sign 3, I should get 0. But if is 9 divisible by 3 by 2? Let's see. 9 divisible by 2. Okay, you get 1. It's not. Yeah, so that's the residue. Just maybe this is giving a bad term. So if I use 19, or I don't know, like 19, okay. So I'm getting, technically speaking, when the number is not divisible by the second number, you are going to not get a 0. So this is usually used, and you will use it a lot when you check to see if a number is perfectly divisible by another number. All right. So that's what this condition means. Now I'm using that in that logic with number 2 because being an even number means the number is divisible by 2. So I'm using this to filter out the numbers that are even. So if this condition is met, if I if I divided by 2 gives a 0 residue, then print I is an even number. Else, well, the number is either even or it's not. Yeah. So if it's not, then just you print that it's an odd number. Okay. So as you can see, it goes through the looping through the numbers. 1 obviously is odd, 2 is even, 3 is odd, 4 is even, and so on and so forth. So this is again another involved example of using the for loop to sort of generate something like a bit more creative example, would you say? But please, in your own time, try to run these codes, yeah, so that it starts making sense and you become really familiar with it. I'm sure all of you are, I mean, you're all university students, so you're clever. I know you pick it up fast, but ultimately it requires a lot of practice for you to fully sort of become comfortable with this, okay? Initial, what is this? Should I run through this? Yeah, let's run through this because this is quite cool actually, as we will be using it. So we're going to call a number called counter. Okay, I know I've used the word initial there, but I'm just going to call it counter here. So let's say we have a counter and we call it 0. Okay, so we have a counter. Let's just go even like that. So counter is definitely 0. Counter. 100%, it's 0. Now we're going to run a for loop, okay? And what did we create a list here? Well, we haven't, have we? So let's just create the list as well. So my list equals, right, I don't know, 7. Let's just call it that. I was creating a tuple. Well, I want a list actually. All right, and that's my list. Yeah. Now, if we want to update this counter for whatever reason, yeah. So for I in my list, okay, let's make it simple. Print I, just so that it acts as a refresher. So very basic for loop, all right? So we just walked through and printed the numbers. Well, happy doopy, okay? No problem. But we want to sort of maybe count these numbers or get it like updated somehow, all right? What if I come and change this printf statement and I say counter, okay? Remember, counter is 0 at the moment, yeah? Counter equals counter plus 1, okay? Just pay careful attention to this. So counter is 0 at the moment. I assure you it is 0, yeah? And we checked it, didn't we? But I'm going to run a for loop. And look at what I'm looping through. I'm looping through this list. It's a list of 6 numbers. 1, 2, 3, 4, 5. I know that one is called 7, but technically it's 6 numbers. All right? So I'm going to loop through this, but I'm not doing anything with the list. Rather, I'm updating the value of the counter. Okay, and how do I do that? I'm saying counter equals counter plus 1. Shall we see what happens? I'm going to run that. Well, nothing really exciting happened, did it? All right, except under the bonnet. Yeah, there is something quite exciting happening, and that is now counter is 6. All right. You will be using this extensively, all right? Now, for those of you who have had experience with programming, I'm sure you have done it in other languages, and you would know where this comes useful. But the philosophy of what I did, yeah? So please pay attention to what we did. We have a list. I didn't care about the elements of this list. In fact, just so that we're sure that, this is nothing to do with numbers in the list, I'm just going to, okay, I'm just going to even do that. Okay, so definitely no numbers in that list, yeah? And L, right? So we have a list of some letters, okay? And I'm running a for loop to update a counter, all right? So let's reset the counter. The counter is 0, all right? Shall we check it? Counter 100% is 0, all right? And I have a list, which is A, B, K, Y, L. And I'm looping through my list, but I'm updating the counter based on the number of elements in my list, all right? So when I run that, I have what? 5 elements in there. Now, pay attention to something else. So please just pay attention here. Let's say for a second, I sort of, for whatever reason, forgot. Did I run this code or I didn't run this code? Oh, let's just run it again. I forgot. Now let me check counter again. It has become 10. All right. So firstly, that counter is getting updated. And every time I run the for loop, based on the number of elements in this list, it's updating my counter. All right. This is a very important step. Try to definitely understand what this is doing. Yeah. Usually, I mean, in here, we didn't use the items in the list at all. We just used the numbering. But sometimes you may want to run a for loop, do something with this list, and also update the counter, right? Just make sure that what you're doing, just as usual, the for loop, there is an indentation, okay? And the counter is getting updated by whatever rule that you want it to be updated. Right? It's quite important for you to understand this concept of what happened here. So if you are confused about this, practice with it, write this code in its simplest form first, understand it, and then you can expand with, like more sort of complicated example. I mean, here I'm showing let's just do this as well, but I'm going to show it like with a different, I mean, we're using a for loop here to convert this string to uppercase, yeah? Obviously, we can do upper as it is, but just for the sake of seeing how for loop is used, again, as an example. So we have a string, which is South Bank student. We are looping through that string. As we are looping through it, we don't say print just I. We could just say print I, yeah? But instead, within the loop, at each operation, we are using the upper function, which is going to convert the letters in that string into uppercase, yeah? So as you can see, it loops through, sees S. S is already uppercase. Well, upper, it's upper anyway, S. Sees the O, which is lowercase, converts it to uppercase, and then prints it out, and so on and so forth, yeah? So in your own time, try to run these examples and play with them to become more and more comfortable with the for loop structure. Okay. All right, the while loop, yeah? The while loop. This is again another important tool that we use. So this time, remember last time I used counter and set it at 0. Shall we just go short and call it k? So I'm initializing something called k to 0. But this time I'm going to use while. I'm not using for loop. I'm using the while loop. While k is smaller, while k is smaller than 10, okay, print f string, print f string k is k. Shall we just put value here maybe? Value is k. What are we doing? All right. Okay. But before I run it, and before if you're coding along with me, let's see what would happen. Yeah. So k is 0. I'm putting a condition. While k is under 10, okay? While k is under 10, print value is k. All right. If you look at the logic of this code, well, k is 0 and it's definitely under 10. What is going to happen? Well, I assure you, it's going to run forever. Okay, so if I run this will run so long as there is electricity and your computer is working, yeah, and you're alive and you're in the same room and that computer is connected. This will go on till infinity, until your computer dies, yeah, or like next century or whatever. Because k is remaining as 0, okay, so the condition of k being under 10 is not altered, yeah? But what we can do during this while loop, we can put this command, which is updating k. K equals k plus 1. So the way this is going to work is that it's going to look at k. So this is how this code works. While k, or k, is it under 10? Yes. Okay. It prints this. Then it goes to next line of code, updates k by adding 1 to it. So suddenly k becomes 1. Then goes back to the loop, the while loop, yeah, the k, is it under 10? Well, it's 1 at the moment, yeah, it's under 10. So it's going to print it, but it's going to update it, it's going to become 2. And it goes up until k is basically, bigger than 10. If k falls larger than 10 or equal to 10, it will stop. So the while loop will run so long as the condition is satisfied. While the for loop run the condition provided that the condition was, there, it would just do one cycle, yeah? All right? Or the number of cycles that you govern it. The while loop can just go on forever or for as long as you basically require until that condition is satisfied. So if I do that, it goes all the way to value 9 and it would stop basically after that. Very, very, very important. Yep. Sorry? Th- That's the F string. It's the last week's lecture when we were practicing printing. Yeah. So just for a quick recap, So if I say print, yeah, well, let's do it over here, isn't it? So if I don't put the F string and I just say value is K, all right? Do you see what happened? No, 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 no. Okay, you definitely need to see last week's lecture. So F string is a method of printing. It has absolutely nothing with floating or integer numbers. The way it works is that you do a print, okay, you're printing, then you put F and a string follows that. What you put in the curly brackets within the string, yeah? So notice the structure. Let me just give some space to it, yeah? So look, we got the F, yeah? And then we got a string, okay? So the way it works is that this F enables the string to take on and put values inside K, yeah, inside the curly brackets that you desire. In this case, we are using the K, right? In this case, so F directly followed by string is called the F string method of printing. So definitely go and watch it in the previous week's lecture, right? So when I do that, every time this K is getting updated, it picks the new value of K. You see, when I took it out, it just printed K because it didn't mean anything else, yeah? But if I run it like this, it's taking the updated value because I'm using F string, okay, I'm putting that. So definitely has nothing to do with integer or float or nothing like that. It just enables us to input number into this bracket, curly bracket. All right? No problems, no problems. All right. So we covered the while loop. Now here is where while and if are integrated with each other. All right. And I think it's good if I run through this example with you as well. It better sort of gets you in grip with what we do. So while k is smaller than 10, print f string k is k, all right? And look at that. I'm using an if statement, but have you noticed, guys, the if statement is within the while loop, yeah? The if statement is within the while loop. So I'm going to say print, I don't know, let's say 5 is our lucky number. Bingo, it's 5, yeah? Right. Once again, so important to update k, otherwise this will go till infinity, yeah? And where do we update k? Notice the indentation. I'm 2 indents away now from origin. I need to go back, k equals k plus 1. And if I do it like that, that is wrong as well. Because if it's there, now updating of k is no longer within the while loop. Yeah, if I run this now, it will go on forever because this is outside the while loop. So the condition of k being under 10 remains valid and this goes on forever. But I'm making this condition as part of the while loop, right? So it's going to say while k is under 10, print this. If k equals 5, so you know every time it's looping it and it's getting updated. If it hits 5, print bingo, it's 5. Okay? So I've embedded an if statement in my while loop. And please, please, please pay attention to this indentation. A lot of people will ultimately write code, but the indentation would get you sort of mixed up. Yeah. Anyway, There you go. So if you run this and you see that it just went on forever, 100% either this is moved this way, over indented or under indented. Yeah. Cool. So that's while looped again. I'm gonna just pass this experiment, pass, break, continue. Now there are these statements that you use while looping to, like for example with the while loop. That's break, continue, and pass. Okay. Look at this example. So I have a list K 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm saying for I in K, if I is divisible by 2, that's what you mean. If I is divisible by 2, giving a residue of 0. Pass. Else, print I. And look what happened. Right? Why did it skip numbers 2? Let me write this down. I think it's good if we go through it actually. So K equals 1, 2, 3, 4, 5, 6. Oops. 6, 7, 8, 9, 10. All right, so that's my list. And I'm going to say for I in K, if I %sign 2 equals 0, in other words, is it an odd number? Yeah, then pass. Right? And then I'm using the else statement. Else print I. Okay, so let's look at this first. I'm going to write this. And we're getting numbers 1, 3, 5, 4. Okay, what if instead of pass, I just don't put anything and I say print, I don't know, print high. Okay, let's see. All right, so in this condition, all right, in this condition, I'm looping through if numbers are divisible by 2, yeah, if numbers are divisible by 2, it's printing high. So, sorry, can you turn off your microphone? Okay, so if I'm doing something, it's printing high. Okay, so 1 number is divisible by 2 and number 2 is printing high. All right, you might be like, okay, if you don't want to do anything there and you just want to pick the odd numbers, just delete that. Why do we even put that? All right, so but then we are going to get an error. If we don't want anything to happen, okay, so I don't want anything to happen, I just say pass, right? So pass enables you, so enables you to ask the loop, yeah, or ask the if statement. It's technically saying ignore it, okay? But when you get the other number, you print it. Now, if I wanted to find numbers divisible by 3, obviously the same thing happens. You see 3 and 9 are eliminated. So that's what pass does basically. So if there is a condition met that you just want nothing to be done, you use the pass basically. Continue, it just means continue. I'm not going to spend time on it. It's the same code. I want you to write continue and see what difference does it make. And break. Let's show you break basically. So let's show you break. Okay. So I'm going to do that, but I'm going to change this to break. Okay. So guys, we are going to look to see if a number is divisible by 3. Before we said pass, meant ignore it. Go to next step. This time we're saying break. So look what happened. He started going through the loop, but when this condition was met, it just breaks it. Okay? And stops the whole process. Nothing else happens. Okay? So break is used to basically put a break to the whole thing, stop the whole process. Okay? Again, practice with this, trying to make different, examples in your mind. Obviously, I will try to give you some homeworks that would encourage you to sort of use these more. But yeah, for now, just be familiar with this pass, break, and continue. Now, handy operators. Yeah, let's look at these. These are some of the handy operators. Guys, there are many handy operators. Yeah, I mean, like handy. That's not handy. Handy. So handy operators. These are, I just show some of them to you. These are what you use frequently in future as tools that enable you to sort of make your life easier when you're trying to code. So one of them, which is quite important, is range. So for I in range, okay, 10. Okay, for I in range 10, print I. Okay, what does it do? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what does this 10 mean? Okay, so it basically goes from, for I in range, it's by default starting from 0 all the way to 10, but not including 10. So this by default means start from 0 till 10, but not including 10. Okay? So technically it would generate 10 numbers for you, but 10 is not included, okay? Because you already start from 0, right? That's how Python starts. That's the range function. But you might be like, all right, I want to sort of have a sequence of numbers, yeah, like, or an order. So you can say for I in range, I don't know, for I in range 100, let's say we want to do so, but we want to go in between. So we want to start from let's say 1 to 100 at the steps of 10. Okay. So from 1, let me write it here, from 1 to 10, sorry, to 100 at steps of 10. Okay. And I'm going to say, sorry, print I. Okay. So it's going 1, 11, 21, 31, 41, 51, 61, you know, so on and so forth, yeah, at the steps of 10. What if we wanted to sort of get number 101, the number 100 itself? What if I do that? So it's going from 1 to 101, all right? What I'd like you to do on your own time, see how can you play with these numbers, try this at home. So now you try this method by changing the numbers in the range argument to get 1, 10, 20, okay, all the way to 100, right? I'd really like you to try that. See how can you change these numbers to try to get 1, you know, or 10, 20, 30. Try to play about with that. Yeah, see if you can get it actually. Is it possible? Yeah, definitely try that. So that's a range. It will be very, very, very useful. Okay. Let's go to the next one, the enumerate function. Enumerate, I'm not going to write it here, but enumerate basically goes through a string. Okay. It goes through a string and creates tuple pairs of like tuples of every element and its index value. Okay. In other words, so it picks out L, it's at index 0, at position 0. O is at position 1. And it just outputs these tuples for you. Okay. Because I want to cover functions with you today, I'm not going to spend more time on this, but please type it in your own notebook so that you become familiar that it's available. How often you use it? Someone like me doesn't. I don't really use enumerate because it's not applicable to the type of work I do. But you, especially if you're working with text or text stuff, if you're doing NLP, stuff like that in future, definitely something that would be quite useful. Yeah. So you need to be 100% familiar that it exists and what you can use it. It's a very good operator. Here we are doing enumerate tuple unpacking. So I insist you remember when I spoke to tuple unpacking about tuple unpacking earlier on, try to run this code and understand what is tuple unpacking in this context. Yeah. Remember in the previous example we did for ing when we made a for loop. All right. Okay, so the zip function, zip basically zips a list, elements of a list to another elements in a list, and it just gives out a set of tuples basically. So I'm not going to spend time on it for the moment, but again, know that it's available. This is quite important. So this enables the in, min, and max. They're very handy. So in generates a tuple. So is 2 in the tuple 1, 2, 3? Yes, it is. Yeah. So this can be quite often used, especially when you have a ginormous list. Yeah. So if you have a really, really large list and you quickly want to check if a number or a value is present in a tuple or a list or something, you use it and it can give you a true or false, or you can use it as a condition for your code to go ahead or not go ahead. Yeah. So for example, if 2 in 1, 2, 3 print yes. Okay. Okay. Else print no. You know, so using the in can be quite helpful when later on you develop more complicated code and you want to sort of operate something provided that a number is within a list or a tuple, all right? So it will come very, 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 very important. The min and max, of course, they give you the minimum or maximum values in the tuple or list or something, yeah? So min, max, I'm sure you can remember them quite fast. Extremely important. Try to memorize them. The random library now, all right? Now, what do I mean by random library? Let me just increase the size, all right? So let's take a look at this code here. So I'm going to say list A equals 1, 2, 3, 4, 5, 6, 7. All right. So that's list 1 or list A. Let's just go list A. So that's my list A. Okay. So if I call list A, obviously I'm getting numbers 1, 2, 3, 4, 5, 6, 7. All right. There are these functions that you can use to sort of do some stats stuff basically, or maybe like do some implement some randomness in your data. And I'm sure many of you have played cards. Yeah. What if you want to shuffle these numbers? Yeah. What if you want to shuffle these numbers? So I'm going to say shuffle. Yeah. Actually, I'm not going to type that. Shuffle. I'm going to type it in myself. Yeah. Not using the Google command. Shuffle list A. All right. So I'm shuffling list A and I'm hoping that it's going to shuffle the numbers. Name shuffle, yeah, name shuffle is not defined. Then you might be like, Ali, why are you telling us, a command that does not exist? Now, many of you might have heard that why Python is such a great language. Basically, what makes it fantastic is the existence of these libraries, and you will appreciate and get to know these libraries further when we go to machine learning, deep learning, data science part of our work, yeah? Because at the moment we are still at Python fundamentals. The libraries are like packages so you have Python built-in functions, okay? So like print a statement, I don't know, we just tried a lot of this stuff, yeah. But then there are operations that are being constantly updated and produced by developers around the world, and constantly making Python a very live language, very vibrant, with loads of extra packages that you can add on to it and make it more sort of powerful. These are called libraries, and obviously they are free. It's not like you have to pay for them. And all you need to do, for example, you see I got an error here. What I need to do, I need to go from the random library. Yeah. So from random. Now, random here is not something in Python. Random itself is a library. Okay. And I'm going to import shuffle rand int, and I'm going to import random. Okay. So it's like there is this shop or this store allocated for Python. It's called random, and it has some packages that you can freely go and upload. Yeah. So when you start your new cell, your notebook, if you haven't imported it, your notebook in that page doesn't have it. But once you say from random, import this. So if I do that now, it's now imported. So shall we run this now? Okay. So I'm gonna remember shuffle before gave us an error, but now I have imported it. So what do we get? All right. You might be like, oh, we got nothing. So let me just write that note here. Random is the library, and we are importing three packages, or three methods, or three, let's just call it three packages for simplicity from it. But packages is not the right thing, yeah? They are methods really. So let me just put Python. So method or functions, right? So I did shuffle list A. So what happened? Has anything happened to our list A? Let's look at it. So list A, okay? So it definitely has permanently changed it, okay? And he has shuffled it. Now it's funny, if I do this again, it will change it again. So if I say shuffle again, and I call list A again down, okay? So every time you run the shuffle on a list, it will do that for you. Now you might be asking me, or why would I want to do that with my list? Well, again, it's application wise. You may need to do it for whatever reason that you are doing it, or you may not ever need to use it, but that's what a shuffle does, basically. And you can't do it unless you import it from the library, yeah? From this library. The other is rand, yeah? Go on. Uh-huh. You mean it's not shuffling? Okay. Uh, you mean if is that what you mean? So if I put, you mean if you say list A like that? Yeah, of course, yeah. Because that's a good question. Look, you run the shuffle, it shuffles it once. Once he has shuffled it, list A is now has a new shape to it. Yeah, so I'm gonna run it. This is my list A now. Okay, so he shuffled it. So if I keep calling list A, of course it's the same thing. Okay, it's like, did you understand? So shuffle operates once. Once you've done it, it has shuffled it. If you like to shuffle it again, you need to run it again. So if you call the list A is now permanently with this order. Now we good? Yep. Yep. Uh-huh. Well, well, sets. the sets, I wouldn't go to sets because sets are already unordered. So when you have a set, it's not guaranteed to have the same order. But you said, can we do a tuple? So let's try. So top equals 1, 2, 3. Okay, so that's my tuple. Does it work on the shuffle? So I go shuffle, top. Oops. Okay. Now read the errors always. Yeah. It says tuple object does not support item assignment. These are really good questions, by the way, guys. I'm glad that you're asking because this means you're thinking. And like you might even ask, does it do it with the libraries? Does it do it with this and that? Usually when these sort of questions arise, straight away try it. All you need to do, create a tuple and do it. And then read the error if it's not doing it. Yeah. So you read the error, tuple object does not support item assignment. All right. So it means it doesn't work on the tuple, for example. All right. No problem. Then we got the rand int. Rand int is quite important. Rand int. Okay. What's rand int? All right. Rand int, let's just say 10. Missing one required positional argument. Okay, what is that? I just gave a number to it, so if I just do that now, it gives 1. So rand int requires a range, yeah? So again, I want you to read the error I got when I put random.randint. Why does it say random.randint? Remember, it means because we pulled it off from the random library. Missing one required positional argument, which is B. All right. So basically, I'm saying from 0 to 10, generate a random number for me. From 0 to 100, generate a random number for me. From 4 to 100, generate a random number for me. So it wants a start and an end. Okay. Does that make sense, guys? Yeah. So I'm asking from first number, first argument to last argument, choose and pick a number for me. Okay. So technically speaking, I mean, like if you buy lottery tickets and you don't want to buy it yourself, like to choose the numbers yourself, and you're really bored at home, you can use the randint to help you choose some numbers if you're buying lottery tickets. I don't know, like if the Python is going to give you a better luck, but technically that's what it does. All right. So it just enables you to choose a random number. Again, you might be like, why would I want to do this? These become more important in future. When, for example, you are doing something and you want to test your results by randomly selecting one of your thousands of values, and you basically ask the program to randomly choose one so that you don't choose it yourself to impose any form of bias into that. All right. Random. So, and then the random itself, it just generates a number from 0 to 1. Okay, like natural, normally distributed random number. But we get to these later. So these are all the main reason I brought this on, because from next week onward, I try to go into introducing other functional libraries associated with machine learning, deep learning. This was like a little introduction to what these libraries are. What do they mean? So when we get there, you're more comfy with that. Input function. All right, what's the time? I think I need to leave it for the next occasion this time. All right, because I'm getting quite knackered myself. I'm sure you guys have had a busy day as well. So guys, I'm gonna call it off for tonight, and then we catch up from next week. All right. So we leave it to, yeah. So from next week, basically, we would carry on with functions, input functions, and functions. We will also cover how we make functions ourselves, yeah? How we create our own functions in Python. Yeah, Joseph? I see your hands is up, Joseph. Yeah. All right. Yeah. Yeah, I will post all the recordings and I will post this code as well. Don't worry about it. And as usual, send me emails if you have questions. Send me private emails and ask me question or anything. And I will try to post the homework as well for this week. Definitely try find some time to do the homework. It really really will help. Okay, dokie. Well, guys, I'm knackered now officially. So I'm gonna say bye for now, and I'll see you next week. All right? No problem at all, guys. All the best, guys. Take care. Bye bye. Bye bye.